Okay guys, welcome back to my channel and I will give a summary of chapter 8, which is the subnetting of IP networks. So before we start, subnetting IP network. Subnetting is very important to the networking in order to know where the data should be delivered, and as part of its IP, uh, subnetting, or what they call subnets. So start. So the chapter 8 is all about subnetting IP networks. So under ops IP network, we have the what we call broadcast domains. Broadcast domains, each router interface connect a broadcast domain, and some broadcasts are only propagate with its specific broadcast domain. So as an example of a broadcast domain, I have a different switch. I have three switches connected into a switch. Then a switch is connected into a router. Then the router is connected into an internet. So it is an example of broadcast domains. So uh, also it encountered problems with large broadcast domains. So if your broadcast domain is so large, so you may encounter slow network operation due to the significant amount of broadcast traffic, slow device operation because a device must accept and process each broadcast packet. So we have a problem, so we also have a solution. So as a solution from problems with large broadcast domains, first is reduce the size of the network to create smaller product or smaller broadcast domains in a process called subnetting. So subnetting can be compared in a hyperthreading of a processor, and the main subnets is the main process, and the subnets are the threads. So the smaller network space are called subnets. Then why subnetting is important in the networks? So network administrators can group devices and services into subnets that are determined by location. So it is the subnets also with, its own IP and the content host. And network administrators can group device and service into subnets that are determined. So subnetting IPv4 and network. Under of subnetting an IPv4 network is the octet, or what we call octet boundaries. Subnetting networks the octet boundary. So it is logically explained. Prefix length, or prefix lengths we use for example, it is /8, /16, and /24. That corresponds to different hosts, different numbers of hosts. So then we have the what we call classless subnetting. Classless subnetting, or under of classless subnetting, is the /25, /26, /27, /28, /29, and /30. /25 is borrowing 1 bit from port. Octet creates two subnets supporting 126 hosts each. So then /26 borrowing 2 bits creates 4 bit 4 subnets supporting 62 hosts. So biggest you borrow, and the more biggest you borrow, it may lessen the number of your hosts. So but also it can give more subnets but lessen the numbers of hosts that will use in each subnet. So for our subnetting to meet requirements, and in the chapter 8 we have to use the what we call BLSM, uh, or what we call variable length subnet mask subnets of varying sizes. Then one subnet was further divided to create 8 smaller subnets of 4 hosts each. Then we have the types of VLSM, which is basic VLSM, which introduce you basic counting of subnets and the addresses. Then also we have the BLSM practices. We have a lot of BLM basic. Uh, it is shown in the NetAcad, but for better result, you need to go to the internet and search, find more about VLSM, and it's even better to watch a VLSM tutorial in order for you to more understand it and more evaluation for it, and also use VLSM practice. It's considered as there are many BLSM practice in the internet, also in the NetAcad. You can use it in order to practice your skills. So let's go with the addressing schemes, the network address planning, and the planning to the address network. Then we have the design consideration for the IPv6. Then for our IPv6, so, it's needed to use the IPv6 global unique address normally consists of a /48 global routing prefix, a 16-bit subnet ID, and 64-bit interface ID. So subnetting using the default subnet ID, then we have the uh, what we call the increment subnet, the IT to create a subnet. So subnet is converted into hexadecimal by its own calculation. Then IPv6 subnet allocation. For example, a router it's all IP address and its subnet is router is connected having connected with 2 switch and 2 PC. So the subnets are the 2 PC and this 2 switch connected only in one router. So it's an example of an subnet allocation. So your summary is all about implement an IPv4 addressing scheme to enable end-to-end connectivity in a small to medium-sized business network. Then also given a set of requirements, implement a VLSM addressing scheme to provide connectivity to end users, then also in a small to medium-sized networks, and also to explain design considerations for implementing IPv6 uh, in a business or in a network. So overall, our chapter 8 subnetting IP network using VLSM, and even it is IPv4, especially for IPv6, because IPv6 is quite complicated than IPv4, so it should use the VLSM. And then upon completion of this, you should be able to know how to use the VLSM addressing scheme because it is important. And then have the basic configuration. uh, from the interface. When you are using routers, the interface serial, and if you are using switches, which is the interface VLAN, writing the IP address needed or the assigned IP address on a particular switch and a particular router. So that's all for the chapter 8. Hope you understand, hope you learn. Thank you for watching.